So 11.8 is expected value. So to find the expected value of a game of chance, we're going to multiply the monetary gain or loss for each possible outcomes by its probability. And then we are going to add these products. So if you took quantitative reasoning with me last semester, we did expected value. So how much they're going to win or lose, and then multiply that by the probability. So for example, we did, back in intermediate algebra, we did something where it was like, if they flip a coin, if you land on heads, you win $1. If you land on tails, you lose $1. So what's the expected value of landing on heads or whatever? So you win $1 out of 1/2. So your expected value would be 0.5, 50 cents. So if you play it a lot, you usually end up with 50 cents in the end. So let's do some examples. The table shows claims and their probabilities for an insurance company. Use the table to answer parts A through C. The amount of claims to the nearest 50,000 and the probability of it happening. So part A says find the expected value. So you have to find the expected value for each one. So I'm going to do another column. So the first column will be, let me do some rows. In order to find the expected value, you have to do the money times the probability. The money times the probability. So 0 times 0.65. So we're multiplying these two together. So 0 times 0.65 will give us 0. Thank you. Next, help me out. 50,000 times 0.23. 50,000 times 0.23. What did you get or what did I get? Because I did it on the board. Which one?
11,500.
Thank you. 11,500. Same concept for the next one. We're going to multiply straight across. So 100,000 times 0.06. What did we get? 6,000. Thank you. Same thing for the next one. 150,000 times 0.04. What did we get? 6,000. Last two. 200,000 times 0.01. What did we get? 2,000. And last but not least, 250,000 times 0.01, 2,500. So notice the expected value going up top is we're going to multiply the monetary gain or loss, which we did, for each possible outcome by the probability, and then we're going to add all these together. So our sum is our expected value. So adding all of these up. So we have 0. 0 plus 11,500 plus 6,000 plus 6,000 plus 2,000 plus 2,500. So adding up this column that we got, what is our expected value? 28,000. And this is our expected value. So that'll be part A, 28,000. We took the monetary value, the money, we multiplied it by the probability, and then we added them all up. Money times the probability and added them all up. That's it. That's expected value. Part B, how much should the company charge as an average premium so that it breaks even on its claim costs? What does it mean to break even? What?
So your profit takes care of what you pay.
Right, so in order to break even, the income, the money that's coming in, has to equal the expenses of the money that's going out, so they have to be the same. So your income has to equal your expenses. We know our expenses, we know our expected value, the expected number that it's going to cost us is $28,000. So that means our income, the money we should charge to come in, should also be $28,000. So this is our expected value. So it should also be $28,000. Our expected value, that was the money that we would have to pay back the people for their claims, was $28,000. So that means if we're paying out $28,000, that means we should charge $28,000 to come in. So that way it breaks even. Same concept. How much should the company charge to make a profit of $50 per policy? So we know that the policy is going to cost the company $28,000. So in order to make a $50 profit, how much should they charge? What? Yeah, $28,050. So we know it's going to cost us $28,000. Plus we want to profit our $50. So we should charge $28,050 because it's going to cost us the $28 to break even, and then we're going to gain the extra $50. So we said in order to break even, we need to charge $28,000. But now if we want to get $50 more than the breaking even point, $50 more than $28,000 would be $28,050. So that's our first example. How could I help you? How could I help you? So if not, let's do another one. This is the one where you really need to write small. Fair warning. An architect is considering a bid for the design of a new museum. The cost of drawing the plans and submitting the model is $19,000. The probability of being awarded the bid is 0.4. If they get the bid, the anticipated profits are going to be $47,500. Resulting in a possible gain of this amount of money minus the $19 for the cost that they had in order to make the plans and do the model. So what is the expected value in this situation? So remember, going back to find expected value, we have to multiply the monetary gain or loss by the probability for each outcome. For each outcome. So if we were to submit a bid, what are our two outcomes? Either they say yes or they say no. Those are our two outcomes, right? So what if they said yes? What if we got the bid? So if we were awarded the bid. Let's just focus on that part right now. If we were awarded the bid. We have to find our gain and our loss times our probability. So first we have to find our gain or our loss. To see how much money we're going to gain or we're going to lose. we know is the profit minus the cost. The money you're going to make minus the money it spent you to make the product. So it told us our anticipated profit. If we get the bid, how much money are we going to make? $47,500. Minus how much was it going to cost us to make the plans and the model? $19,000. So how much would we gain or lose? Thank you, $28,500. $47,500 minus $19,000 will give us $28,500. So for our expected value, if we were to be awarded the bid, remember, is our gain or our loss times our probability. We said our gain was $28,500. If we were awarded it, after our cost of actually making it, we would have $28,500 left over. That would be the money that we gained. Times what was our probability of actually being awarded the bid? 0.4. 0.4. So our expected value was that $28,500 times our probability of getting it, which was 0.4. So our expected value will be $11,400. $11,400. That's if we were awarded the bid. That's if they said yes. Now we're going to go through the same exact process. And what if we were not awarded the bid? We went through all the effort, but they said no. Questions so far before we do that? All right, so that was our first one. So what if we were not awarded the bid and they said no? Same thing, we have to find our gain or our loss, which is our profit minus our cost. If we didn't get the job, how much profit are we going to bring in? Nothing, zero. But how much did it cost us for us to submit the bid, for us to go through the process of making the plans and the models and all that? $19,000. So our loss this time, it's negative, is negative $19,000. Because it's negative, we have a loss. Obviously, we didn't get the job. That stinks. So now finding this expected value. Same thing, we have our gain or our loss times our probability. We said this gain, or in this case loss, is $19,000 times what was our probability of not getting the bid? They didn't tell us, right? Yeah, 0.6. How'd you get that?
1 minus 0.4.
Right, so they told us the probability of getting it. So we know the probability of getting it is 0.4. So find the probability of not getting it is 1 minus 0.4, which is 0.6. So that means probability of not awarded is 1 minus the probability of awarded, 1 minus 0.4, which is 0.6. So negative 19,000 times 0.6. This time we get negative 11,400. negative 11,400. So our total expected value is the sum of all expected values. So adding up all expected values, which we got 11,400 for the first one, plus negative 11,400 for the second one. So 11,400 minus 11,400, what's our expected value? 0. So the probability, the expected value for awarded, the expected value for not awarded. So our final answer is 0. So if our expected value is 0, does that mean we break even, we gain money, we lose money? Break even. If it's 0, we're going to break even. So for part B, choose what this means. So we're going to break even. So A. If it was a positive number, we'd be earning this amount. If it was a negative number, we'd be losing this amount. I apologize for the lack of space. Okay, thanks. All right, questions for me? A little bit on the more challenging side because there's different parts to it. We have to put all the parts together. But questions for me? Questions for me? We have one more example. One more example. Are you ready? So it is expected that there are 17, oh, this is great, that there are 17 deaths for every 10 million people who use airplanes. A company that sells flight insurance provides $100,000 in the case of death in a plane crash. I hope that value more than $100,000. So a policy can be purchased for $1. $1. So calculate the expected value and thereby determine how much the insurance company can make over the long run for each policy that it sells. So if only 17 people out of 10 million die, if 10 million people are paying $1, you know, it's like seeing whether they win or lose money. So same concept as the previous. You have two options when you get on that airplane. You're either going to make it out or you're not. Yeah. Okay, so without making this too morbid, either you die or you live. So let's do death. Let's choose that you die. So same thing. We have to find, just like before, our gain or our loss. So that way we can multiply that by the probability that you're going to die. So remember, is the profit they're going to make off of our death minus the cost. Profit minus cost. So how much money is the insurance getting from you? $1. If you die, how much is it going to cost the insurance company? How much is the insurance company paying if you die? $100,000. So that means 1 minus 100,000 will be negative 99,999. So that will be our gain or our loss. For our death option, our expected value is the gain or loss times the probability. So if our gain or loss is negative 99,999 times, what's the probability you're going to die in a plane? 17 out of 10 million. 1, 2, 3, 4, 5, 6. So at least you have like decent odds, I guess. All right, so multiplying this together, negative 99,999 times, in parentheses, it's its own fraction, 17 over 10 million. Bless you. We're rounding it to the nearest cent. We're rounding it to 2 decimal places. So before we round this one, let's just kind of leave it. So negative 0.1699983. I don't want to round it till the very end. I don't want to round it till the very end. So that's if we die. Or let's not say we. That's if the person dies. That's the expected value. Now that we're all depressed, let's do the expected value if they live. So no death. Should I put live? Probably. Death or life? I'm going to do this in green so that way I can easily see it. If they live, again, we have to find the gain or the loss, which is the profit minus the cost. If you live, how much is the company getting? How much did you pay the company? $1. If you live, how much does the company have to pay out? 0. Then I'll pay you if you make it. Which is 1. So our expected value is our gain or our loss times our probability. So we said our gain or our loss is $1. Times our probability. They don't give us the probability that we're going to live, only the probability if we're going to die. So we can do, just like before, 1 minus the probability that you die, which is 17 over 10 million. So 1 times, in parentheses, 1 minus, another set of parentheses to make this own fraction, 17 over 10 million. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. And we get that expected value is 0.99999. 1, 2, 3, 4, 5. 9s. 8, 3. Oh, sorry, never even seen what I was writing. So putting this into our calculator, we get that expected value. So our last step is just to add these two numbers together and we get our final answer. So that number minus, because it's negative, 0.1699983. And we get 0.83. That's already rounded for us. That is our final answer. So our final answer is the 0.9999983 minus 0.1699983. And that's our total expected value. Remember, our total expected value is we are going to take our two different options, either you die or you live, those expected values that we find, and then add them together. This problem, I wanted to add it in the notes. It's exactly like the previous one, but the numbers are just so ugly because we have like 10 million or something like that. So questions, comments, concerns for me, 11.8.